Now remember from the last video, we were trying to find the function which is described by the area underneath the curve. So here we have an arbitrary curve. Now if I have a look at an area under the curve, and I can say, okay, what is the area we have under here? And the area we have under here, if this is x, is equal to the function we're looking for, would be a big F of x. If I want to have a look at the area here, this is a position x plus h, f of x plus h is going to give us the whole area also coming from 0 to this point here. So what we then want to look at is, what is the area of just this little bit here? And the area of that little bit here is going to be the difference in those two areas we've described so far. So that we know that our area under the curve is going to be the f of x plus h minus f of x. And this will give us the area of that little sliver that we've got there. Now when we have a look at that, we can say, well, we know the area is going to be greater than this part on the left side. That is equal to our f of x times the area, which is x plus h minus x, times h. And so we know that that area there is going to be less than or equal to the area under the curve there. If we then have a look at the next little bit, is we have a look at, okay, what about the other side of the equation there? And we can say we've got this little extra bit here, and we know that that is going to be bigger than the area under the curve in that point. So we can say this is less than or equal to, and we've got our f of x plus h, again, because we're after the area, times the gap of the distance here, which is equal to h, times h. So when we have a look at this very carefully, we can think about this. We've got h on the left and h on the right, so if we divide through by that, we can then go f of x is less than or equal to f of x plus h minus f of x, which is less than or equal to f of x plus h. And of course what I have to do then is I've divided by h through on both sides. X and x plus h closer and closer together, so that f of x plus h is equal to a very small amount bigger than x. Then we're going to end up with the same as we had before when we're talking our limit as h goes to 0. So what that means then is that if we look at what happens as h gets very, very small, so this sliver gets closer and closer and closer and closer and closer, so it's very, very narrow, we can say that f of x is less than or equal to the limit as h goes to 0, x plus h minus f of x, which is less than or equal to the limit of f of x plus h. So when we've got this now, we can see that as we said h goes to 0, then f of x plus h goes very close to f of x. So what we're really saying is that now the left side and the right side in this case are equal. So this means that what is in the middle must be equal to f of x. And if we have a look at this very carefully, then we will see that the part in the middle here is that d f of x dx is equal to limit as h goes to 0 of f of x plus h minus f of x over h. If you remember that from when we did derivatives last class. And so what we're really saying is that f of x, which implies that f of x is equal to the derivative of big F of x dx. Or in fact, what we are saying is that integration is the anti-function to differentiation that we learnt last week. And this is finding the area in the curve is simply integrating that function that as we learnt last week.